This video we are going to draw the Lewis structure of NO2, that is NO2 Lewis structure or nitrogen dioxide Lewis structure. We'll also discuss on NO2 formal chairs, NO2 hybridization, NO2 molecular geometry or shape, or NO2 polarity, that is NO2 polar or non-polar, and also I will show you the resonance structure of NO2. So let's get started. Look, NO2 has 3 atoms, right? The nitrogen is an element of group 5a, that is why it has 5 valence electron, and oxygen is an element of group 6a, that is why it has 6 valence electron. But here we have 2 oxygen, so we have to multiply by 2. So we are getting 5 plus 12, that is 17 valence electron totally. This 17 valence electron has 2 tasks at the same time. Remember, this 17 valence electron has 2 tasks at the same time. The first task is to connect these 3 atoms together, and the second task is to satisfy the octet of all the atoms. So let's get started. So let us connect. So in NO2, nitrogen is least electronegative atom. So nitrogen is the central atom and oxygen are the outer atom. So let us connect. To connect, we have to use 2 dots, right? 2 dots or line. Look at here. 2 dots or line. This dot means this line. This line means 2 dots, right? So now we have connected. So 17 out of 17 for connecting we have used 4. So how many electrons left? Look. So 3, 1, right? 13 valence electron left. Now you have to satisfy the octet of outer atom first. So we have 13 electrons in our hand. So this oxygen has 2. So we have to place more 6. Now this oxygen has 8, and so after using 6 we have 7 valence electron left. So this oxygen has 2, so this oxygen will take more 6 to satisfy its octet. Now you have 1 valence electron left, and this valence electron must come over nitrogen. Look, this oxygen has 8, this oxygen has 8, but this nitrogen has, look, this nitrogen has only 2, 4, 5 valence electron. So now you have to satisfy the octet for this nitrogen. That is why you have to move the lone pair as bond pair, right? So if you move this lone pair as bond pair, what will happen? Let me show. We will move this lone pair as bond pair. Sorry, we will place here, right? So we are getting this structure. Now this nitrogen has, look, this nitrogen has 4, 6, 7, right? That is actually odd number. If you move one more electron, then nitrogen will have 9. So if you move this here, then this nitrogen will have 4, 8, 9. That is that exceed the octet number. So this is fine, right? So this is the Lewis structure of NO2 or nitrogen dioxide, right? So you can express this structure. So here you can place 2 double bond here. Then this oxygen will have 6, right? And this oxygen will have 4, and here 1, right? So look, this is the this or this is the Lewis structure of NO2. Now let me show you the resonance structure. So this oxygen has double bond. So you can also make this oxygen as double bond. So this is the sign of resonance, right? So what will happen? You have to move this electron here, and this electron will come here. So what is happen? This is nitrogen. So here double bond oxygen. This single bond. Then this. So these two structure is the resonance structure of each other. So nitrogen dioxide has two Lewis structure, right? Now let me tell you the formal charge of NO2, right? That is the formal charge of oxygen, nitrogen and oxygen. So you know that formal charge equal to valence electron. The valence electron in a neutral oxygen atom is 6, right? Minus half of bonding. So here 4 bonding electron, so we have to take half, right? Then we have to consider the lone pair. Half of bonding, you can write this structure like this, minus lone pair, 4 here, right? So we are getting here 6 minus 2 minus 4, that is 6 minus 6 equal to 0. So the formal charge for this oxygen is 0. So let us find out the formal charge for nitrogen, right? So let me show you the quick way to find the formal charge. Already I have shown you the actual way. Now let me show the second way to find out the formal charge. I think I will apply this second way to nitrogen atom. In a neutral nitrogen atom, we have 5 valence electron. This is known to us. And here nitrogen, we have assigned, look, 1 valence electron, we have to count all the lone pairs. So 1, then we have to consider half of the bonding. So here bonding 4, we have to consider 2. So here 2, we have to consider 1. So 1, 2, 3, 4. So here we have assigned 4. So 1. So the formal charge of nitrogen here is plus 1, right? The formal charge of oxygen is here. Look, in a neutral oxygen atom we have 6 valence electron, and here we have, look, 2, 4, 6 and 7. We have to consider 1 for half of the bonding. So 6 minus 7, that is minus 1. So the formal charge for this oxygen is minus 1. So if you add, then what will happen? Plus 1 minus 1, that is 0. 0. So overall NO2 molecule will have 0 charge, right? Because the formal charge is the addition of formal charge becomes 0. So now you can you have knowledge how to find out the formal charge, right? Now I will show you the hybridization of nitrogen and oxygen, right? So look, so for finding hybridization we have to find the electron region. So look, nitrogen, here we have getting lone pair, that is 1 electron region, then here 1 electron region, but here one bond is sigma bond and another bond is pi bond, right? In a double bond you will get 1 sigma bond, another pi bond. Actually pi bond doesn't take part in hybridization, so we have to consider double or triple bond as a single electron region. So look, nitrogen has 3 electron region. That is why 1 s orbital and 2 p orbital will take part in the hybridization process. That is why this nitrogen is sp2 hybridized. So this oxygen is also sp2 hybridized, and this oxygen is also sp2 hybridized, right? So now I'm going to give you the idea of the molecular geometry of NO2, that is nitrogen dioxide. Since sp hybridization is happened, so this molecule NO2 molecule should be trigonal planar, but due to presence of this lone pair over nitrogen atom, this molecule is bending, right? This molecule is bent to some extent, bending molecule, right? So V-shaped, you can say, to some extent, right? So the molecular shape of NO2 is bending like V-shape due to presence of lone pair. In ideal situation, since it is sp2 hybridized, so its shape should be trigonal planar, but due to presence of lone pair, it is bending or V-shaped. Now I am going to discuss about the polarity of NO2 molecule, that is NO2 polar or non-polar? Look, nitrogen is least electronegative, so the dipole moment for this bond direction will be from nitrogen to oxygen, and for this bond the dipole moment's direction will be like this, right? Look, this bond is polar because oxygen is more electronegative than nitrogen. So this bond, this is partially negative and positive. This is positive and this is negative. This oxygen is negative. This oxygen is negative, right? So this bond and this bond is polar. Now the net molecular dipole moment is not zero because this bond's dipole moment and this bond dipole moment doesn't cancel each other due to the bending shape of NO2 molecule. That is, the net dipole moment for NO2 molecule is not zero. That is why NO2 is a polar molecule, right? So from this video we have learned the Lewis structure of NO2, the formal charge of for how to find the formal charge for NO2, and also we have learned the hybridization of NO2, and also we have learned the molecular geometry or shape of NO2, and also we have learned the polarity and resonance structure of NO2. So thanks for viewing this video. Be well.